Hello, it's Scott Manley here, back with another episode of Deep Space Questions. Episode number 21. There are a lot of questions in deep space these are all from my supporters over at Patreon. If you want to help me out, go over there and take a look. There is some small amount of exclusive content. And of course, if you answer questions there, I will eventually get around to answering it, hopefully. So we're going to start out with Lorenzo Simeonato. Hi, Scott. How are the mission trajectories calculated? In particular, when it comes down to gravity assist, launch windows, etc. Now, I'm going to presume that you're talking about deep space interplanetary mission trajectories, because you're talking about gravity assists. And for that, a lot of the basic building blocks come from something called Lambert's problem, where you basically say, I'm at this planet in this orbit, and I want to arrive at this planet in this orbit, and I want to leave at specific time t, and arrive at time t2 here. And you can figure out exactly what orbit you would have to be on to do that. And then, because you know what orbit you're on and what orbit you have to get onto, you can figure out the delta V at both ends. Now, you can then use this to make what's called a pork chop plot. That's where you basically vary the start time and the end time, or the start time and the transit time, and you plot those out, and it forms these weird contour plots. And they look a little like pork chops, hence the term pork chop plots. And in the middle of that, you're going to find areas where the delta V is the lowest, and that will be typically close to ideal Hoffman transfer trajectories. Now, that is just the first step. That is how to get from one orbit to another. You can pick your arrival time. Now, the next thing you can do is, well, what happens if you get a gravity assist from that planet at the other end? Well, you can actually just say, well, if I arrive at time t, and I want to get to the next planet at time t2, you can do the same calculation. And the other thing you'll do is you can calculate the hyperbolic fly past, where you basically assume that you come in from deep space at infinite, come in from infinity, follow a hyperbolic trajectory past the planet, and shoot off to infinity. And there's a very simple equation between the velocity you arrive at, and which is identical to the velocity you depart at, and the angle through which this is bent. So if you then calculate, the Lambert's problem for the next step of the trip, you can rule out anything where the delta V change is not within the capabilities of this kind of fly past, right? So what you can do is basically try to iterate through by changing the start times, and that kind of really cuts down on your search space. So you're basically just adjusting the times and looking for those ideal trajectories where you chain together all these different things and minimize the amount of delta V. That's really how it works. And once you've got some candidate trajectories, that's when you sort of go to the next level and start to zero in on the exact operations, navigation, and so on and so forth. I think that's a pretty good explanation. Alex asks, I watched Apollo 13 several times, as have many of you out there, and always wondered if they changed the CO2 scrubber afterwards so they could be used as a direct replacement, even if it's even been required again. And the answer is no, they didn't change that. The hardware was already, in many cases, built, so they didn't do anything with that. And honestly, Apollo 13 proved that they didn't need to do that because they had a procedure to use the square pegs in the round holes, and that happened to work. And they just needed to make sure that future missions had all the bits of hardware so that they could do this. There were other changes that they made. Specifically, they looked at the propellant tanks that were used by the fuel cells, and they added an extra one. They removed the fans for the stirring and the thermostats, and in the command module, they also added a water tank, because one of the problems was that they were running low on water since they expected the fuel cells to be making that. So yeah, they never made any changes to that, but and of course it all worked out in the end. Udo Richter, once again asking, will we ever get to see Asparagus staging on real launch vehicles? What do you think? Which one of the launch vehicles currently in operation or development could be modified easiest to be flown in an Asparagus configuration? Okay, so Asparagus staging is something which I think I've heard it mostly talking in relation to Kerbal Space Program, right? But the idea is if you have something like the Falcon, the Delta IV, right? You've got three boosters there, and they burn in sequence, and the middle booster burns typically at 70% throttle, so that when the outside boosters use up all their propellant, it still has like 30% of its propellant left. Now, the idea with asparagus staging is instead you have pipes like that feed fuel from the outside boosters into the central booster so that it's always at 100%. And this is much more efficient in terms of mass because you're basically not carrying all that extra tankage on that core. And this is something which is very easy to do in Kerbal Space Program. So people don't do it with just 2 boosters, they do it with like layers and layers of boosters to get the maximum performance possible. But in real life, it's very difficult to take that fuel crossfeed and feed it into that propulsion system without messing things up. And nobody's ever really managed to get that. The nearest I've seen is a space shuttle, where you have this external tank and that's feeding into the engines, but it never switches between one fuel source and another. Now, SpaceX had originally talked about doing this with the Falcon Heavy. They saw that this would vastly increase their payload capability, but as the Falcon Heavy got developed, what happened was the base Falcon 9 also got better. Those Merlin engines managed to really increase the amount of payload that could be carried on a base Falcon 9, and that edged out the capabilities that would need the Falcon Heavy. And so needing even more payload capability is just not there. There's nobody asking for that next step that's willing to pay for the extra development costs. Also, Falcon Heavy has a pretty small fairing, so it doesn't really, even if you could put like huge amounts of mass on top of it, it would have to be all very compact and hard to do. So Falcon Heavy is the one they looked at, but they never actually made that happen. It would also still be the most likely to happen, make that happen, except that of course Starship is going to, ultimately steal its thunder and its sonic booms. Yes, boy, can you believe a Starship super heavy sonic boom? That is going to be a monster thing. We also had things like the Delta II, which would have 9 solid rocket motors at launch, and it would light 6 of those, and halfway through the flight they would drop 6 and then light the last 3. So that's sort of something similar to like a Kerbal staging scenario, but it's not really asparagus staging. Okay, Tobin Warner. What are your opinions on using the moon/space to dispose of nuclear waste? Could be used for thermal electric generator for a moon base. It makes no sense to throw nuclear waste into space to dispose of it. First of all, you got to understand that there's various levels of nuclear waste and very stringent controls, and the vast majority of radioactive waste is actually really low radioactivity. It's nothing to worry about, and it certainly doesn't generate enough heat to be thermally useful in a cycle. But the other thing is, throwing stuff into space takes a huge amount of energy. What you would really think about it wouldn't be so much disposing of the waste as exploiting the waste. And there's companies actually that are planning to do this. They're proposing this, things called nuclear diamond batteries. So a lot of reactors include graphite as a moderator for neutrons. And they've shown that the graphite does actually absorb some neutrons, has a very low neutron absorption cross-section, but it can happen that you get carbon-12 ultimately transformed into carbon-14. And carbon-14 has it's what's used for carbon dating. It has like a half-life of about 5,700 years, I think. So there's companies, their idea is you can skim off you can basically process the graphite to selectively remove the most carbon-14. And they find that the carbon-14 highest densities are actually found right at the surface. So they I think what they plan to do actually is they plan to heat up the graphite to sublimate off the carbon-14 at the surface. And then they're going to take that and make it into diamonds. And from making these thin film diamonds, apparently they can do it in layers and make it produce a small amount of electrical power. But this is not something that would power a moon base. It is something which could be used to power small electrical devices. Such as pacemakers. Remember the pacemakers that used to have plutonium-238? Yeah, that's a special thing. Okay, moving onwards. Wow, this is a big one. Brad Allen has been toying with the idea of having 1 million people, with each family living on their own farm-sized estates with Wait, is this about space? Oh, Mars-like conditions. Okay, so it's like Mars homesteading and requiring on the deeds of those living there. Basically, okay, so this is like, hi, we're going to do homesteading on fake Mars as a way of researching real Mars. Well, that's a very grand idea. I think that here's the thing, if you're gonna learn those skills and technologies for living off the land on Mars, the place to start is on like high plateaus where the pressures are lower, the temperatures are a lot lower, basically high deserts where it's just too cold for vegetation and too cold and dry for vegetation to really live. Like I'm sure there's mountains in the Andes that qualify for this. Then build out greenhouses. It'd be a bit like Biosphere 2, and in fact you'd want to operate it like Biosphere 2, which is in Arizona, but even lower temperatures that we'd be having to deal with. There's an interesting, so there's some interesting analogs here. Yeah, Biosphere 2 is a sort of one side of that. Analog astronaut programs where basically astronaut candidates they learn about living and working on another planet in a confined module and doing experiments on the surface. And they do this like in Hawaii, up in the side of a volcano where nothing lives and the terrain is inhospitable. Another example another interesting data point here is the ESO, European Southern Observatory Hotel that they have up in the Andes. So the European Southern Observatory is a bunch of telescopes at high altitude in the Andes. And the astronomers stay in this amazing hotel, which it was just like a barren hole in the ground. They put like a glass roof on it. They have these buildings and hotel rooms that look out. And inside, underneath this glass dome, they have like a garden and a swimming pool. And it's like a greenhouse. Outside, it's like the surface of Mars. So look, if you're going to learn homesteading for Mars, you have to start on Earth somewhere. Another place would be some of the locations in the Antarctica. The only problem with that is that they are dark, several months of the year, and that it's not really good for plants, and it's not an accurate analog of Mars in that sense. Okay, El Machian. Hi Scott, another Bay Area techie here. Hey, West Coast, Best Coast. I know that most chemical engines use bipropellant. Makes sense. Fuel plus oxidizer plus spark. Boom. Or hopefully burn, because boom would be a hard start. But are there any chemical rockets or concepts that use tripropellant or more? Can you achieve more by adding different chemicals to the combustion process? Yes! Many years ago, I made a video called WTF are rocket fuels anyway? And right at the end, I said, hey, bipropellants, what happens if you're crazy enough to try tripropellants? Well, they did actually come up with a tripropellant design, which is better than any other bipropellant rocket. This uses lithium, fluorine, hydrogen, right? So these you get 3 propellants. Hydrogen has to be kept at like 20 Kelvin. Fluorine is a sort of higher level cryogen, and lithium, you have to keep it at like elevated temperatures so it's liquid. So the lithium reacts with the fluorine, creates this very energetic reaction, and then you add in the hydrogen and that increases your specific impulse just by getting blown out. I think the specific impulse of this was higher than any other chemical engine, but also it produced electromagnetic interference, which was like, because there was so much energetic ionization going on, the plasma would actually interfere with radio signals. So yes, they do exist. No, they are not practical. There's another sort of tripropellant concept, which isn't quite the same thing. That's the RD-701 engine, which was used in the Soviet MAX spaceplane. This would fly on the back of an AN-225, and it would take off and fly into space from there. Now, it had a tripropellant engine, but really what it was a bipropellant engine with 2 different modes. Initially, it would use a high-thrust kerosene liquid oxygen cycle, and then once it got higher up and it needed the higher performance, it would switch over to hydrogen and oxygen, and that would carry it all the way into orbit. So that was a concept. It never flew, but it's a cool thing nevertheless. Rajesh King. Is it at all possible to have an astronomical object with liquid oceans of water, nitrogen, titration, whatever, without having significant atmosphere, where the gravity alone is enough to hold down the molecules instead of atmospheric pressure. And yes, okay, so what we're really talking about is vapor pressure. And the higher your vapor pressure, the more likely your stuff is to evaporate. Water, as you know, if you bring the air pressure down, the boiling point drops until it goes, basically to the freezing point, and it's just bubbling and boiling away. Now, water's actually quite good at this, but a great liquid which doesn't boil in the same way as water is mercury. So mercury, you can get down to something like 1 Pascal. So that's 100,000th of an atmosphere. And basically, yes, if you have a perfect vacuum, it will boil just enough to fill that with 0.000001 atmospheres of pressure. And that's why you have these mercury barometers, where you would have like a U-shaped tube with a vacuum on top of it, and depending upon the height difference between the mercury, you could tell the atmospheric pressure. When I go flying, the pressures get read out to me in inches of mercury, right? 29.92 inches of mercury is a standard atmosphere, and that's the sort of central point of the altimeters. There are other liquids that are slightly better. I think glycerine, or glycerine is slightly better, and it's used, like one of the interesting uses of glycerine is when you're doing set dressing in movies and you want a thing to look wet, and you don't want it to dry off under studio lights. You'll put glycerine down because its vapor pressure is so low that it's not going to evaporate. It's not going to naturally evaporate into the atmosphere. Other things are, water is actually pretty good in terms of vapor pressure. I think it's like 2.5% of the atmosphere before it starts really evaporating at room temperature. Anyway, let's move on. DB Explorer. Hello. So question, with reusable launch vehicles becoming the norm and heavy launch systems like Starship coming soon, do you think the use of dedicated orbit-to-orbit systems like a cycler will get more serious considerations? It seems to me that allowing ships to specialize in leaving the planet or traveling the void of space would make sense after the first Pioneer missions to a planet. So, cyclers, they do make sense, but not for everything, right? If you're sending people back and forth to Mars all the time, that absolutely makes sense, because people, they don't like being locked in a tiny cabin the whole time. They need to carry heavy life support systems to recycle everything. So if you are regularly moving people back and forth to Mars, it makes sense to have a space hotel cycling on these routes, and the people check in for a few months and they live there, and then the thing continues through deep space and eventually comes back and picks up another load of astronauts on the way back. It doesn't make sense for cargo. Cargo doesn't care how tightly you pack. Well, okay, it generally doesn't care how tightly you pack it. It doesn't need to have the same level of environmental control. So those could be sent direct, and you do pay a delta V penalty to hit the cycler and be able to rendezvous with it and then undock from it. But for cargo, if you're sending it direct, there's no reason to send it up to a cycler. So it may happen if you regularly have this kind of transit going to and from Mars. But that would require a serious number of people going to and from Mars. Finally, we have Daryl Nelson saying, what, in your opinion, is the worst space project undertaken? Not where the rockets exploded or crashed, but ones where the results were either pointless or not what was expected. Okay, so I think one of the most ridiculous projects flown in space as part of NASA was the jet shoes. Actually, I'm not sure it got flown, but jet shoes basically were some guy wanting to show that you could fly around inside the space station by having little air jets in your shoes. And I don't know, Iron Manning it around. It was apparently not considered to be particularly good. So much so that Deke Slayton, head of the astronaut corps, actually asked for it not to be flown on Skylab. So it may never not have actually been flown, or it might have been flown under a different name. It looks pretty ridiculous nevertheless. I have a video on these kind of human propulsion systems in space. I also have a bit of video, by the way, on the ugliest rockets ever. And while I can't say that none of those were successful, so they were all very ugly, and the ones that weren't successful should never have been built. But yeah, So yeah, I think actually the project, okay, I'm going to be controversial here. The project that really didn't achieve anything and was kind of pointless by the time it launched was the Soviet Buran shuttle. And I'm going to say, I love the Buran in many ways. There's so much cool stuff. It's a tragic story, but clearly they put a lot of love into building this near copy of this American spacecraft. And Russians will argue that, oh, actually, no, that design was stolen from this. And listen, both nations made advances in spaceplane technology, right? But look, by the time Buran launched, it was very clear that the space shuttle was not living up to the promises that had been made of it. Beyond that, Buran, it threw away a lot of the reusability. I mean, so obviously the US reused those boosters, although didn't really save them that much. But the engines, like the Buran had no real engines that were used during ascent. All of the engines were on the core on that Energia rocket. And they pretty much had to build the Energia for Buran, and it only flew like twice. Buran itself only flew once and then ended up too expensive and decaying away. And it is really, really unfortunate because there's definitely something very cool about Buran, but I think ultimately, as a pragmatic, neutral observer, it was a waste of money and time and effort. Although I'm sure they probably learned a lot of things about what not to do. Yeah, so yeah, that's my answer. A lot of deep space questions and a few near space questions. And yeah, if you'd like to ask the questions, feel free, join the Patreon. And apparently there's a bunch of different ways you can send me messages. I don't always get around to all of them, but I am trying to keep up with everything. Thanks for watching. I'm Scott Manley. Fly safe.